Today we're going to look at logarithms and what exactly logarithms are. The only thing that I think you need to remember is logarithms are really exponents. In the old days, many years ago, astronomers used to be transfixed by the stars. And they spent many hours studying what was in the skies at night and looking at planets, stars. And one of the things they wanted to do was find the distance from Earth to these stars, and then again find the distance between these stars. And of course we're talking about huge numbers here, and they couldn't quite comprehend how to deal with all these numbers because they knew they were big, but they needed to find a simpler way of working with these numbers. Let's go back to our law of exponents, which says, if we look at our law of exponents, it says a to the m times a to the n equals a to the m plus n. And for instance, if we had 10 squared times 10 cubed, that would equal 10 to the power 5. So if we had 1,000 times 10,000, we could do it in powers of 10, couldn't we? Because 1,000 is 10 cubed, and 10,000 is 10 to the 4th. Add the powers together, that would give us 10 to the 7th, which I believe is 10 million. And a 1 with 7 zeros. So pretty simply, that's how it works. What they found out many years ago was that any number could be written as a power of 10. So 786 would be 10 to the power something. Let's see if we can work this out. We know that 10 squared is 100, and 10 cubed is 1,000. And as 786 lies in between these two numbers, 786 will be 10 to the power 2 point something. These are the logarithm tables that were developed 300-400 years ago. And if you look on the left-hand side here, you'll see a number that says 10. And that, if you look to the first column here, has 0, 0, 0, 0. So that's telling you that 10 equals 10 to the power 1.0000. So we've already assumed that the 1 exists for 10 to the power 1. And the decimal part that goes after it are all the 4 zeros. So if we added that on, this number here would be 10.1 because the 1 is up there, and 10.1 would be 10 to the power 1.0043, and if you do that on your calculator, you should get 10.1 as your answer. And in the same token, 10.2, which would be this line here, and then 0.2 should be that number there, which equals 10 to the 1.0086. Well, how about 101? What would 101 be? Well, the same thing. We'd still look at the first two digits of 100, which is 10, and then we'd be in this line here, 100. And the 1 means we go to the 1 digit. So we're still going to use these numbers 0.0043, but now we know that 100 is 10 to the power 2, so it's 10.0043. And again, we should get 101. Now what I'm going to do is we're going to zoom in here because it's not really ideal circumstances to really look into this file. So now we're going to find out what 786 is as a logarithm. We know that it's in between 10 squared and 10 cubed. So therefore 786 is going to be 10 to the power 2 point something. So we're going to look down this column here to try and find the first two digits, 78. And 78 is here. So we know that we're on that line there, 78. And we go across to the sixth column, which is here. And we should be looking at this number here. And that, if I can highlight it a bit further. Maybe I can't highlight, but anyway, not a problem. Should be this. Oh, I've done a bit crazy there, but that's fine. So there's the number we want, which is exactly 8954. So what we can say is that 10 to the power 894. Try and get rid of this yellow. Sorry about that. Let's go back to black. 10 to the power 8954 should be our 786, and you can check that on a calculator. So how did this help people in the old days? That 8954, 821 is there, and 9143. So if we'll check that, 9143, completely wrong. So now, if we look to multiply 786 times another number, let's try 821, which are easy numbers to multiply, but in the old days, perhaps add 5 zeros to each number. We could do it by powers of 10. We already know this is 2.8954. And let's see if we can find out what 821 is. So 2 to the power 8943. I think I've got that wrong. Let's just go back and rub that out. I can't do it. Okay. So that is 2 to the power 9143. Let's just cross it out for now. 9143. So the law of powers says a to the m times a, law of exponents, is a to the m plus n. So this should equal 10 to the power 2.8954 plus 2.9143. And if we add those powers together, we get 2 to the power 5.8097. Now what we're going to look for on our chart now is just a decimal part of this. So we're looking for 8097 in the middle here. And 8097 is about there. 8096 is very close, so we go to the left and we find 641. We go to the top and we find 645. So therefore this equals 645. And because we've got a 5 here, we know that's 10 to the power 5, which is going to be 100,000. So it's going to be more than that. So this is going to be 645,000 as our answer. And all we need to do now is check to see if we got the right answer. And if we look at our numbers up top, 786 times 281 equals 645,306. So just going on the base numbers we've got here, we are 306 out in our calculations just on these basic tables. Now, if you imagine these are 4 decimal places, in the old days they used to have log tables for 7 decimal places. So how does this help us? Well, the great thing is we don't have to worry about history too much, and we can move on to the questions we're going to be dealing with. And what you're going to see is questions like this. Log base 2 of 8 equals x. And what this says is, if you ask yourself in details, what power would you raise 2 by to get to 8. So that's it. Basically what that logarithm is saying. What power would you raise this number by to get to this number? Well, instantaneously, you'd say the answer must be 3, and you'd be right. So working on that logic, log base 10 of 100. What power would you raise 10 by to get to 100? Quite easy, 2. Log base 3 of 9. What power would you raise 3 by to get to 9? Answer 2 again. How about this one? Log base 2 of 16. What power would you raise 2 by to get to 16? And the answer is 4. Well, of course, now it gets a bit tricky, because as soon as I put something in like this, what power would you raise 9 by to get to 27? Well, we have to come up with a different way of working. I call this the log rotation. So whatever number goes here, we write down. Whatever number's here becomes the power, and this number goes to the other side of the equal sign. What number connects 9 and 27? Well, 3. We know that 9 is 3 squared. And then we've got the x outside. We know that 27 is 3 cubed. What do we do with the powers here? Well, we multiply. Law of exponents, we get 3 to the 2x equals 3 cubed. And now, because we've got both 3 and 3, we can say that 2x equals 3 and x equals 3 over 2. So go back to your original question. What power would you raise 9 by to get to 27? Answer 3 over 2. So here are 7 homework questions. Try them and see how you get on.